In our last video, we operated under the assumption that the torque required to turn this nut with a force applied at the wrench, so we'll say that the torque at the wrench equaled the torque required with a force applied at the nut. And so my question to you is, would the same thing be true? So torque equals torque no matter where you're applying it. Would the work equal the work? So would the work at the wrench equal the work at the nut? And to figure this out, we need to know, well, we obviously know that work equals force times distance. But we would have to know the distance traveled by each force. So what would be the distance traveled by the force applied at the wrench? So let's write a question mark here. And what would the distance traveled by the force applied at the nut equal? And let's keep our math super simple. Let's just assume we're trying to find the work with one rotation of this wrench, or therefore one rotation of the nut. So let's just say we're assuming that we are just measuring the work done with one rotation of each force. And so we actually already halfway done with what we need to know to find our work for each one. So we could say work at our wrench equals our force multiplied by our, and I'm going to pick my color here so we know what we're looking for, our distance traveled by the force at our wrench. And over here, and I'm actually going to pick a different color for our work done at our nut. I'm going to say our work done at our nut is equal to, again, our force, which we already know, multiplied by our distance traveled for one rotation of that force at our nut. And so all we have to do is find the circumference of the circle that each one of these forces would create. So again, let's start with the distance at our wrench. Well, okay, what is the formula for the circumference of this circle here? Well, it's just 2 pi r. And of course, I could rewrite this to say, well, 2 times r is our diameter, so I could just say diameter times pi. And what is our diameter? Well, our diameter would just be double our radius, and our radius we said earlier was 6 inches, so it would be 12 inches, and since we're measuring work in feet in foot-pounds, we would just say, well, 12 inches is 1 foot, multiplied by essentially pi, which we'll just say is 3.14. And we don't even need a calculator to solve this. What's 1 times 3.14? It's just 3.14 feet. And so that's our circumference. We can even just plug that in right here. We could say our work done at our wrench in one rotation would be equal to our force, which we said earlier was 20 pounds, applied to our wrench would be the required force to create the torque needed to turn this, multiplied by our distance, which we just found for one rotation would be 3.14 feet. And so to figure this out, let's just type it into our handy dandy calculator. We'll say 20 times 3.14, and we get 62.8, okay? So we can just write it out. We could say the work done with our force applied to the wrench in one rotation is 62.8, and then feet times pounds is of course just foot-pounds. And so now we know what the work would be at the wrench, but again the question remains the same. Would the work done at the nut be the exact same here? And so to figure that out, we would just do the exact same thing with our different distance. So our distance traveled by one rotation of our force spinning around our nut, this force nut is, again, well, it's just the circumference, right? So it would just be 2 pi r. And okay, we know what our radius is. We could change this again to say 2 times pi multiplied by our 1/12 feet. So 1/12 of a foot. And of course, to find the diameter, we don't have to find the number. We could just start working from here, actually. We could change the form of the diameter if we want to, but there's really no reason to. We just say 2 times 1/12 would be 2/12. So we could rewrite this to say our distance traveled by our nut in one rotation would be our distance of our force applied to our nuts, I should say, in one rotation should be 2/12 feet multiplied by pi, which we'll just say is 3.14. And actually, I want to show you something kind of cool here. Let's plug this in as is. Let's say that this is the entire distance, which it is. It is equal to our distance, as we said. So since this is equal to our distance, we're going to plug that in for our distance. So let's say the work done at our nut is equal to our force, which we said was 120 pounds. 120 pounds multiplied by our distance. And let's actually move this up just a little bit to make ourselves some room to write the rest of our equation here. So back to writing it out, we can multiply that by 2 over 12 feet times 3.14. And something really interesting happens here. We could say 120 times 2 divided by 12 in our calculator. So let's go ahead and say 120 times 2. We get 240 divided by 12. And what do we get? We get 20. And so basically, we've combined both of these numbers here. We can cross these out and we can replace them with, well, actually, it'd be better if I say we combine these numbers like this. We get 20 foot-pounds. So we say equals 20 foot-pounds multiplied by this pi, which we said was 3.14. And as you see, we end up with the exact same equation here as we got earlier, 20 times 3.14. And so we say our work applied at our nut is the exact same equation here because, well, it's 20 times 3.14. And when we plugged that in earlier, it's not going to change. Math doesn't change. As it turns out, math always works. So we could just say that this is 62.8 foot-pounds as well. And so to answer our question that we asked at the beginning, yes, the work applied to the wrench does equal the work applied to the nut. And of course, that makes sense. We are doing a job. We are turning this nut around one time. We are completing one rotation. And that is the same job whether we do it from the wrench or we do it from the nut. So yes, work equals work.